Hey everyone. So in the last few videos, we have been looking at agents, retrieval augmented generations. But one thing that we skipped is what is a good way or the best way to get your domain data ready for you to apply these agents and retrieval augmentations. We wanted to kind of cover this topic before we go further into the agent systems, right? So um, what have we seen so far in terms of getting your domain data um, ready for your getting the domain data into vectors so it's ready for your RAG and agents, right? So in the last videos, um, we looked at a simple example where um, your domain data is in this array of string where in your case in this the domain data is here is like a list of errors, and we simply use embedding model instantiated ran created into vectors, and that is being stored into vector database, right? um, but not all your database or your domain data would start from an array of string, right? Mostly your data would be in some kind of a file, um, um, or it could be in some kind of a websites and whatnot, right? So what is the best way to extract the data from different sources, process the data, and store it into vector database as a embeddings, right? So in this video, we're gonna look at that particular process. So as part of LLM libraries, we also provide few libraries that helps in your data preparation pipeline. How can you get your domain data uh, and store them as vectors, right? So there are three major flows in this data preparation pipeline. One is a data source reader. Second is data processing steps. Third is data destination. Data source reader is nothing but okay, it's all classes, uh, all abstracted classes. It reads the data from some source. In this case, we have a X file reader, we have a web page reader, and you can also create your custom reader because your data might be in some proprietary format or in some proprietary sources, right? So you can always kind of create it's a plugin based system, so you can kind of create a class inherit from a data source reader, and that class you just point to a source and it just reads the information statements. The second set of um, steps are once you have the information read from the data source reader, um, we have list of data processing plugins or steps. Again, this is again a plugin based system. You can kind of create your own processing steps that you wanted. By default, we have some processing techniques because um, not everything would be like all your data might be like split into chunks or nodes, right? You need a step that takes your big if you have a word document, you want to take the word document and cut the word document into several meaningful smaller pieces so that it can be stored and retrieved correspondingly. So uh, we have data processing steps that is chunk by characters, chunk by paragraphs and whatnot. And we also have a embedding step which converts your uh, chunked nodes or documents into vectors, right? We also put this is also a processing step, right? Your vectorizing is also processing on your data source, so that's also part of the data processing. And the final one is the data destination plugins. Here, the primary one that we have is a vector database store. You just point a vector database and point your data, and it just stores in the data destination. So this is a simple pipeline, right? Pipeline contains a reader, a processing step, and a destination, and all these are like array of like steps or objects that you actually give it to your pipeline class, and all the pipeline class does is it just sequentially executes them, takes the data from one step, gives it to the next step, processes it and gives the final step and stores it, right? This is what the data pipelining class would do for you, right? um, we will quickly look at a demo explaining how simple it is for you to um, take your data from a source and store them as a vector. So let me open LabVIEW here. I'll close this VI. I have an example called the data preparation pipeline. It's a very simple example. Um, um, the one that you see in the right side, three sub VIs are simple pipeline steps. Sorry about that. Um, One is instantiate pipeline. It gets the different source readers, processing plugins, and destination plugins as an input. So it gets array of source, array of processing, array of destination as an input, instantiate it. When run hits, it actually executes it and actually stores them and destroys the instant of this particular pipeline object. Right? Simple three steps that you can actually drop. Now, the important thing is this is very simple. How you initialize these steps are the ones that you wanted to note. And again, it's not too complex as well here. Uh, we have a simple text reader. So all you do is you point a folder to it, and it can recursively look at files in the folder and consume all the information and store, right? For example, all your domain information, if it is present in some kind of a um, like a folder or location in a drive, you can just point to the folder and it just takes all your domain information from, I mean, if it's going to be text file or empty file or any text like a file, it just loads that from that particular source. In the data processing, we have two data processing steps. One is it chunks um, all the sources with each chunk carries 500 words, kind of. So it's called split by characters, and 500 is a character length, and you can configure the character length. The second one is just an embedding model that says what embedding model that you want to use to um, vectorize each of these chunks. And the final one is just it just gets the database information, and it just says where you want to store this information. Again, now when you run it, um, the source loads all the files from the source. It's documents, chunk cuts each of the documents into several chunks, with each chunk having 500 characters. Embedding converts each chunk into vectors, and the database stores it, right? You are essentially now sequentializing your steps and doing it. Again, you can add more chunk steps you wanted. You can add more database or vectorization steps that you wanted, and you can also store more databases if you wanted. All right, that's up to you. Now, if I run this, for example, let's just say I want to create a collection called _1. So now I run this, I go back to the vector store, refresh this. Let me see if collection gets created once the VA is done parsing all the information. It's still running. Okay, it's done now. So if I go back here, refresh it, yep, I see a new collection, and if I open it, I'll see a lot of chunks, and you see each chunk is like probably a 500 character length out here. Now, I want to kind of show you how easy it is to kind of add some new sources or new steps, right? So I also have a web page in my GitHub that talks about my project, right? So all I do is I just point the URL of the website. It's in GitHub, so it's a GitHub user content. It just has my profile and then my repo and what file in the repo. It's just an about.md about file in the repo. We just pass in. I mean, it takes array of URLs. I just provided one URL as an input, and the output is something I will queue it, like, append it to the data source. Now, when I run the system, it takes data both from GitHub as well as the text file and does the same processing and stores it in the uh, vector database. So I have run it again. It may take few seconds. Uh, and if I now open my collections, I think it's done, right? Yeah, it's done. So I see 20 here. So if you look at, I have error information from my text file, but I also now have a few more chunks from my GitHub content, right? It kind of talks about that particular project. So this is a good way um, to kind of prepare your data. Again, it's repeatable. So once you kind of create a pipeline and put this into your system, whenever you have a data change at your source, you can just run it. So you get the new vectors ready for your agents and retrieval augmented generation to act on, right? Um, like all other um, all other classes, the model class, database class, agents class, it's also a class based ones, and it is also has abstraction as a principle. So um, these are generic parent classes. You can kind of create how many ever child data source types, processing steps, and vector database as needed. You can just for the open source project add how many ever classes that you wanted in the data processing pipeline, and you can use it in your system. Um, this is a quick overview on the data preparation pipeline that we have with LLM libraries. Thank you for watching.